In problem 10.4, a bullet is fired vertically into the air and reaches a maximum height of 15,000 feet and is asking for the initial velocity v0. What assumptions must be made? The answer is neglect the effect of air resistance. So if you look at the problem, the ground is here, this is v0, so it's the muzzle velocity, which is not 0, and you can assume that it's also going to be a downward velocity of v0 just by symmetry. We really don't know how long it takes to get to the top of its trajectory, but we do know that at the top the y value is equal to h, which is that value right there. And so what we can do is say y is equal to y0 plus v0 t plus 1/2 a t squared. The acceleration in this problem is, well, you could say negative 9.8 meters per second squared, but the problem is given in feet, so it's better to use negative 32.2 feet per second squared. That's the acceleration due to gravity in feet per second squared rather than meters per second squared. Assume the origin is down at the bottom, so this one becomes 0. That's not 0 right there. We don't know how long it takes to get to the top. What you could do is say this, at the top, ... This y becomes h. You have v0 t plus 1/2, and then you have the acceleration, which we know, and we'll put that in later. The problem here is that you have two unknowns. You know what the acceleration is, the acceleration due to gravity. You don't know what the v0 is, but you do know the height. So there's two unknowns. The two unknowns are the v0 and time. So in mathematics, when you have two unknowns, in order to find them, you need another equation. So for two unknowns, you have to have two equations. So we'll do at the top again, but this time we'll need another kinematics equation. And that equation is our v is equal to v0 plus a t. Making this specific to at the top of its trajectory, the y value. That's the other thing up here, is it, I'm sorry, the velocity at the top is equal to 0. So the acceleration is not 0 at the top, but the velocity is. This is the unknown right there, v0, and this is a known, and this is another unknown. So it looks like we have a second equation here that has two unknowns. So what you do is you're saying, well, you got t here and v0 unknown, and the same thing up here, but we're not looking for time. So what you could do is say time is equal to, let's move the v0 to the other side, minus v0 over acceleration. Let's take this and put it right there. So if you do that, you get h equals v0 times negative v0 over a. So I just took all of this and I put it right there. Plus 1/2 a, and I have to square this, so it's negative v0 over a squared. Okay, I think you can do the rest of this here. Yeah, because the only unknown in here is v0. So you get a v0 squared right there. You'll get a v0 squared here. One of the a's cancels out. I'm going to have to let you do the rest of the algebra to figure out what the velocity is here. So just a few more steps to go on that. Make sure you show all of this work for your homework assessment.